This is section 10.1. This is the second video. We're going to look at coplanar circles. So these are two circles that live in the same plane. Two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar circles that have a common center are called concentric. Okay, so let's look at those examples there. So we have this first part here where you have circles that touch twice. You could also have circles that just touch once. Notice how those are called tangent circles because you could draw a tangent right through there, and that line is only touching both of those circles one time. Or you could have circles that don't touch at all, like this one and this one don't touch. Or you could have two circles that are called concentric. They have the same center. What is a common tangent? A line, a ray, or a segment that is tangent to two coplanar circles is called a common tangent. So here are examples of common tangents. Here are two circles that don't touch. I have one line here that is a common tangent. It touches each of those circles once. Now, if you really want to zoom in there, I know those lines are touching that circle more than once. The intention was to make them tangent, okay? Now, same thing when I go to draw this other common tangent. I'm going to do my best here. That wasn't terrible, but let's say that's a common tangent as well. There could also be one that lives there, or I totally missed on that one, but I'll just cheat a little bit there. Okay, so when you have two circles that don't touch like that, there are going to be 4 common tangents. So I could do the same thing down here with this example here. How many common tangents do these circles have? And you want to draw them. So you're going to have common tangents going diagonally through the circles, like that, and like that. You're going to have one tangent on top of the circles. And I know I missed there. Just do your best because mine are going to be better than yours. Just take my word for it. So 4 common tangents there. How about when the circles are tangent circles? Well, you're going to have 1, 2, and then your third one. Or when your circles touch twice. Oops, missed that one. I'll just make my little dot bigger. 2 common tangents. So you'll see some of those examples on your assignment. Let's talk about theorem 10.1. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. So how do I know that that blue line is, in fact, a tangent? Well, if it makes a right angle with a radius, then, yeah, it's a tangent. Okay, now vice versa. If I do know that is a tangent, then I can draw a radius to it, and it has to be perpendicular to it. That's why that if and only if is there. It means both things. Okay, so we have this blue line. It's tangent to circle Q because that radius is perpendicular to that blue line. And that's really important. You'll see why in a second. Just when you thought you were done with triangles, you're not. Verify a tangent to a circle. In this diagram, segment PT, that's this guy, that's definitely a radius of circle P. And notice how it's telling you it's circle P, so P is the center. Is segment ST tangent to circle P? So in other words, does this triangle, is this triangle I really wish I knew what I was doing. Is this a right triangle? Okay, so this is really the problem here. Does that make a right triangle? Does 12 squared plus 35 squared equal 37 squared? Geez, I wish I had a calculator sitting here beside me. I think it does. There's no way I'm doing this in my head here. If if this side equals this side, then it's a right triangle. I think that it is. If I'm wrong, you can tell me about it. But that's how you would determine it. Just type it in your calculator. In this diagram, point B is a point of tangency. Let's find the radius of circle C. Am I going to be able to do this without a calculator? Goodness, I don't know. Okay, so same thing. If point B is a point of tangency, notice how it intersects with that radius. That makes a right angle. That's what's really important. You got to write that down. That's theorem 10.1. Okay, now that makes a right triangle. So what that means is, let me draw you the right triangle. We got a radius here. We have that leg is 80, and this leg here is r plus 50. Again, you're using your Pythagorean theorem to set up an equation, and then you're going to solve for r. So, again, not sure if I'm going to be able to do this without a calculator, but let's just write it out at least. All right, let's square a binomial. It wasn't as bad as I thought, at least not yet. You have an r squared on both sides. This is different. We haven't done a lot of this year, but they cancel. So you have to solve for r. So I'm going to subtract 2,500 from 6,400. And what am I going to get? I'm going to get 3,900, I think. And that's what r squared equals. Now, what is the square root of 3,900? Oh, God, I wish I had a calculator. All right, so it's going to be a decimal, pretty sure. What if we just did this? 10 squared of 39. Not sure that even makes sense, but hopefully that checks out for everyone who has a calculator out there. So that would mean this guy is 10 squared of 39. And this guy is obviously 10 squared